Hey, what's up? It's your old pal, Mr. Cook, and we are working on the Unit 6 test review. We just got done with the exponent problem, so we're through number 26. Now let's go ahead and work on the solving log expressions. So the solving log expressions are broken into two different camps. One in which you have a log equal to a log. And if you look through, these problems, you've got that for the next four problems. A log equal to another log equal to another log equal to another log. So all four of the next problems have a log equal to another log. Look at the next ones just to compare them. 31 has logs equal to a number, logs equal to a number, logs equal to a number, logs equal to a number. We're going to solve those a little bit different than what we're doing for these first four problems. So let's see what we have to do for the first row of problems and see if they're difficult or easy to solve. Well, if we take a look at these problems, if they have the same exact log base, it's the same as if they have the same exponent base. So do you remember what we did for these ones when they had the same exponent base? We just took the powers and set them equal. Well, it's very much the same for this. If you have a log equals a log, all you got to do is just take the parts that are in parentheses, set them equal, and then solve. So this equals this. So I just write it out. Negative 4r plus 3 equals negative 5r plus 1. Then it's just about you solving the expression and then checking for extraneous solutions. So we're going to check for extraneous solutions at the end. We're just going to get the solutions for now. So to solve this out, I'm going to get rid of this minus 5r. So I'm going to add 5r to both sides. So 5r minus 4r is 1r. So r plus 3 is equal to 1. And then subtract 3 from both sides. R is equal to negative 2. So there's one of our solutions. Number 28. So again, the log equals a log, so I can just set the part that's, in the log, 2k, and k plus 2. I can just set them equal to each other. And then solve. So subtract k from both sides, you get k is equal to 2. So there's your solution for number 28. For number 29, same thing, a log equals a log. So you can set this thing equal to this thing. So negative 3n plus 2 equals negative n. Let's add 3n to both sides. I end up with 2 is equal to 2n. Divide by 2 and you get your solution, n is equal to 1. So there we go. There's our little answer for that one. And then number 30, I have a log equal to another log. So I again can just set these two little equations in the parentheses equal to each other. So negative 4x plus 9 is equal to 5x plus 2, and then solve. So I'm going to add 4x to both sides. So I get 9 is equal to 4 plus 5 is 9, so 9x plus 2. Then I subtract 2 from both sides, and I get 7 is equal to 9x. And then divide by 9, and you get your answer for number 30. X is equal to 7 over 9. All right. So that's how you do these four problems. When you have a log equals a log, you just set the parts in parentheses equal to each other. So that's a bit different for these next four problems, but still, I think that they're just, they're pretty easy as well. You need to use the log properties that we went over on the previous page, so these ones. So we need to combine the logs or condense them and then solve it. So I'm going to condense them first, and we'll see how that looks. So I have two logs that are adding, so they condense into one log that has multiplication. So it's going to be 9 times this other thing, 4x squared. Same thing here. We're just going to combine these two logs. So if I have two logs that are subtracting, that turns into a fraction. Log base 8 of, and then the positive one goes on top, so x squared plus 8, and the negative one goes on the bottom, so over 3. And then don't forget to write out the rest of it. So equals 4 equals 1. Same thing, just combine these two logs together. So if I'm subtracting them, they turn into a fraction. So this is log base 4 of, and then a fraction. X plus 2 goes on top, and then x goes in the bottom. That equals 2. Now combining these two together, you get log base 7 of, and it's another fraction because they're subtracting, x minus 2 over x. That equals 3. Now when you have a log equal to a number, you use the log conversion exponents. So that's what I'm going to do here. I'm going to convert this into an exponent. So it becomes 6 to the power of 4 is equal to 9 times 4x squared. Same thing here, I'm just going to convert it to a log, so 8 to the power of 1 is equal to x squared plus 8 over 3. Same thing here, I'm just going to convert this into an exponent, so 4 to the power of 2 is equal to x plus 2 over x. And then this last one, 7 to the power of 3 is equal to x minus 2 over x. All right, so now that I've converted them into exponents, I just go ahead and solve it out. So this one, let's see here. I know that 9 times 4 is 36. So then if I divide that into 6 to the 4th, that's going to give me 36 as well. And then if I take the square root of both sides, that gives me two solutions. X is equal to 6 and also negative 6. So those would be my two answers for number 31. On to number 32, 8 to the first power is just 8, so I can just get rid of that first power there. And then from here, I see that 8 is equal to a fraction. So what I'm going to do is turn this into a fraction as well, 8 over 1, and then cross multiply. So 8 times 3 is 24, so I get 24. That equals x squared plus 8 times 1, which is x squared plus 8. So now solving this, I subtract 8 from both sides. I get 16 is equal to x squared. Take the square root of both sides, and you get x is equal to 4 and also negative 4, because both of those numbers squared give you 16. So I have two solutions for number 32. Moving on to number 33. 4 squared is 16, so I'm just going to rewrite that as 16. And then, since this is a fraction, I'm going to turn this into a fraction as well and cross multiply. So 16 times x is 16x. 1 times x plus 2 is x plus 2. Then I just solve for x. So I'm going to subtract x from both sides. I get 15x is equal to 2. And then divide both sides by 15. So you get x is equal to 2 over 15. So there's your lone solution for number 33. All right, 7 to the third power. If you use your calculator on that, you get 343. And since this is a fraction, I'm going to turn this into a fraction, so over 1. And then we cross multiply. 343 times x is 343x. 1 times x minus 2 is just x minus 2. If I subtract an x from both sides, I get 342x is equal to negative 2. And then if I divide both sides by 2, I get x is equal to negative 2 over 342. Yikes. And that actually reduces a little bit more. I'm sure you wouldn't need to reduce it, but it becomes negative 1 over 171, yeah. So that would be your answer for the x value here. All right, so now we're going to do the very last thing, which is check to see if we have any extraneous solutions. And if I were you, I would get through all of this stuff first, solving them for the logarithms, then try to do the extraneous solutions, because you don't want to run out of time on your test. So here's how you check for an extraneous solution. You take your solutions, you plug them into the logarithms, and you just make sure that whatever log you're taking, the parentheses value has to be positive. It cannot be negative, it cannot be 0. So let's see what happens. If I plug in negative 2 for r, I get negative 4 times negative 2, which is a positive 8, and 8 plus 3 is 11. So that one works out okay. If I plug in the negative 2 over here, negative 2 times negative 5 is a positive 10. 10 plus 1 is 11, so that's positive as well. So since both of these are positive, this one checks out. It is not extraneous. Same thing for 2. If you plug in 2, 2 times 2 is 4, so that's positive. 2 plus 2 is positive, so both of these check out, so that's not extraneous. But this one actually is an extraneous solution, because if I plug in 1, even just for this one over here, I get log base 6 of negative 1. Remember, the log has to be of a positive number. So if this is a log of negative 1, when I plug it in, it actually fails it. So that means that this is not going to be a real solution. It's not a solution that we can use for a log, so it's extraneous. So I just put a little x next to it to signify that it's extraneous. 7/9, if I plug that into both of these, they'll both be positive. You can double check that with your calculator, so this is not extraneous. If I plug in 6 and negative 6, I'll get a positive because of that square on the x. So both of these work out, and neither of those are extraneous. Same thing goes here. If I square the 4 or the negative 4, they both end up being positive, so both of these are going to check out. And then let's see here, 2 over 15, yeah, both of those will check out, so that'll be a good answer, not extraneous. And then this one, however, since I have a negative It's already a negative number. If I plug it in for x on this, it's a negative number overall. So that means that this one does not work. So this is going to be extraneous. So the two extraneous solutions are going to be 34 and 29. And when there's no solutions that work out, we say that that's going to be an answer that has no solutions on it. So like number 34 and then also number 29, those are going to be ones that have no solutions on them. And you'll see that in class, like when your teacher works through these problems, that they're no solution ones. Okay, so I think that's it for this one, just solving the logarithms. It's broken up into two camps. When you have logs equal to each other, the logs just kind of cancel out or go away. And then when you have a log equals to a number, just like with exponent equals a number, you need to convert it into an exponent or into a log. You need to use that conversion right there. All right, that's it for this page. So now it's on to the word problems and then the graphs.